Hello, students. Today we will start our fifth experiment, and the aim of the experiment is the connection of three-phase energy meter to a three-phase load. So, in this experiment, let us first understand the requirement of a energy meter, then we will understand the experiment. So, to calculate and to measure the amount of energy consumed by a consumer is very much essential. We cannot make the bill more or less according to our suitability. We have to be we have to put or we have to bring the bill in exact amount so that nobody will be a loser, neither the producer nor the consumer. Here, the consumer, let us consider ourselves as the domestic consumers. Now, if the bill is having some errors or the reading of the meter is having some errors, what will happen? If it is overcompensated, then we will be in benefit, and if the bill is or the meter is not compensated, we will be in loss, because the meter will go on revolving after the actual amount of energy is utilized. So we have to take care that neither the consumer side nor the producing side of the electricity are the losers. So we have to be very much careful about the billings. So in this experiment, we will we will connect a three-phase energy meter to a three-phase load. Now, what is a load? Load can be a load box where resistive load, capacitive load, inductive load can be connected. We can also connect a three-phase motor to this energy meter so as to calculate or take the readings of the energy consumed by the particular motor. Now we will run this motor for a duration of 1 hour and we will take the reading. And mind you, students, the initial reading has to be taken because these meters are in cumulative readings, or the reading of the instruments are cumulative. So the initial reading should be noted, and when the final reading has been observed, the final reading minus initial reading will give you the energy consumed. Now, in the apparatus required, we have a load which is of three-phase slip ring induction motor, 440 volts, 12 amperes, and the quantity is 1, and it is used as a load. In the remark side, I have written because we because we can also have a load box instead of a motor, but in this experiment, we have taken a motor. Now, the second thing which we require is a energy meter, which is essentially a three phase one, and its 1 unit or 1 kilowatt hour is for 100 revolution. It is the meter constant. The quantity required is 1. Now we also require combination plier, screwdriver, electrician knife, neon tester, and connecting wires. Connecting wire is as required. The length of the wire, whatever you require, you may take, and you may not you may you should insulate them properly so that they will be properly insulated, so that nobody will be in a risk. I mean to get shocks electrocuted. Now, the theory part. A energy meter consists of iron core, voltage coil, and current coil. So these coils have a current coil which is having less turns of thick copper wire connected in series with load, but voltage coil has more turns of thin copper wire connected in parallel to the load. Current flowing in current coil and pressure coil depends upon the electric load and voltage respectively. The aluminum disc is present in between the two coils. The energy meter operates upon induction principle. The measurement of instrument is necessary to measure energy consumed by load so that proper billing can be done. The manufacturer generally prints the meter constant of each meter. For example, meter constant of say 1000, it means that for 1000 revolution of the meter will record 1 unit or 1 kilowatt hour. These constants may vary from manufacturer to manufacturer. Now, the energy formula is the total power consumed into duration of time, which is equal to root 3 VL IL cos phi or theta. Here I have taken as theta, the power factor, into the duration of time, where VL is the line voltage, IL is the line current, cos phi is the power factor, T is the time duration. Now the circuit diagram is in your video, which will be uploaded after this video. So from there I have explained the connection diagram of a energy meter to a energy load. You have to get the circuit diagram from that video, draw the diagram in the space provided. You have to make a neat and clean diagram. Procedure, now we'll discuss about the procedure. We have to connect the energy meter and load as in the circuit diagram. So this will be written in past form. I have just written in a short form. You have to elaborate it. Check the connection point of energy meter as indicated in the instrument, that is supply terminal and load terminals, or line in and line out. So students, you have to be very much careful which terminals are line in and which are line out. It will be clearly indicated in the energy meters. During starting, note down the initial reading of the energy meter. The load was connected for 1 hour, so it may be to different hours, different duration of hours also. So it purely depends upon you. If you wish to record for more duration of hours, then you may also. So the energy consumed was finally equal to the final reading minus the initial reading. Now conclusion. So from the experiment we conclude that a three-phase energy meter was connected to a three-phase load, and the energy consumed by the load after 1 hour was recorded successfully. Here in this experiment you do not have to write the observation because we do not need any observation table. So this was the experiment. You have some review questions also. Define meter constant, why energy meters are connected, what is pressure coil, what is current coil, what are creeping errors, how to compensate them. So thank you for watching, students.